In this last example, we want to talk about function composition once again. This time we're going to remove all equations. We can do all this stuff without the need of an equation. Sometimes it's kind of tricky to look at the abstract x's and f of x's and things like that, and I think sometimes a picture is helpful. And I want to talk about how we can use these graphs to make compositions of functions or to evaluate compositions of functions. And actually, before we get started, I do have a little bit of a typo here. This function actually shouldn't be m of x. This one should be g of x. So let's call that g of x. And this one isn't k of x. This should be f of x. So that'll fit with our problems a little bit better. A little bit of a typo. So, okay, here I have two functions, and I want to find what f of g of negative 1 is. And I don't need to have an equation. I can just use these graphs. All I need to do is I need to remember that my inputs are my x-axis and my outputs are my y-axis. So let's kind of work from the inside outwards to find what f of g of negative 1 is. Let's begin by finding what g of negative 1 is. And to do that, I look at my graph. Here's my function g of x. And I need to look for where the input is negative 1 and evaluate or find what my output is. So that output is negative 3. So what that means is that I'm going to look for whatever f of negative 3 is. So now I go to my function f, and I go to when the input is negative 3, the output is positive 4. So g or f of g of negative 1 is equal to 4. So I kind of have to retrace my steps a couple times, but it's as simple as that, looking for your inputs and your outputs. Let's talk about what g of f of 1 is. The first thing I'm going to do is I'm going to rewrite this using a different notation, g of f of 1. And let's do what we did before. This time let's go with green, and let's find what f of 1 is. F of 1, I'm going to look at the function f of x. I'm going to go to where the input is equal to 0, where the input is equal to 1, and look for my function. The output, or the y value, is equal to 0. So that means then that now I need to find out what, let's go with, orange. I need to find what g of 0 is equal to. So now I'll go to my g function. I'll go to where the input is 0 and look for the output. And I don't need to move very far once again. This is equal to 0. So it turns out that g of f of 1 is equal to 0. So I can do function composition with equations. I can do it with a graph. I can even do it with tables. If I had two tables of inputs and outputs, I could perform the same process of kind of nesting these values. So why don't you try? I have 3 examples for you. This C is a little bit of a challenge, but I think you can do it. Give these problems a shot, pause the video, and see how you did. All right, and here are the 3 answers to these problems. So you'll notice I didn't have the workings out for this one. You're going to have to see if you can't figure out how to get negative 2x minus 4 if you didn't get there, but I know you got there anyways. So hopefully these went all right, and that's all we have for function review.